Sharma, Assistant Professor EC Department from the college Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to start with the next part of this subject, that is data communication networks, and the topic of today's lecture is channelization. So, till now we have discussed about how the network is formed, what are the different components of a communication, how the channel is established between the transmitter and the receiver, different layers which are involved in communication, because everything you are going to perform is a layered architecture basically. So, it requires the information to be transmitted in different layers. So, for that there are different types of models are there, two types of model. First one is ISO OSI model and second one is the TCP IP model. Then we have discussed about different protocols that are involved for communication. So, today we will discuss about channelization. What is channelization? How the information will be transmitted between the transmitter and receiver, how the channel is formed, whether it is a wired channel or a wireless channel, and how the different users can accommodate or can use a common channel which is established between the multiple transmitters and multiple receivers. Then different techniques are there for channelization, that is known as FDMA, TDMA and CDMA. Full form of FDMA is known as frequency division multiplexing. Full form for TDMA is time division multiplexing, and CDMA is known as code division multiple access. So, what does it mean? That multiple access, if we are going to see what is FDMA, then CDMA and TDMA. Now, two things are common in all the three different modules, that is multiple access. This is common. This is frequency division, this is code division and this is time division, but in all the cases there will be multiple access concept is used. Now, what is multiple access? Multiple access means when there are more than one transmitters are there. Let us say in a network there are 4 users. First user is denoted by U1, second user is denoted by U2, third user is denoted by U3 and fourth user denoted by U4. So, these are the 4 different users that are going to access a common channel, that is shown by this line. This is the channel, this is the common channel, and there are 4 different receivers are there, receiver 1, receiver 2, receiver 3 and this is receiver 4. So, this is the channel which has been established between the transmitter and receiver. So, this is transmitter side and this is the receiver side. So, multiple means more than one transmitters are there and more than one receivers are there. So, and access. So, these are going to access a common channel which is to be shared between all the 4 users and all the 4 receivers. Now, this sharing part of this channel is based on either frequency division or it will be dependent on time division or it is code division. We will going to see each one in detail. So, this is the introduction of today's lecture. Now, next is what is channelization? Channelization is a multiple access method in which the available bandwidth of a link is shared in time, frequency or through the code, which means whatever available bandwidth we will have for the channel, it will be equally shared by n number of users. There may be 1 user, there may be 2 user, there may be 3 user. We have taken in the earlier slide, we have taken an example of 4 different users are going to accommodate a common channel. So, that sharing will be based on time, it will be based on frequency or it will be based on a code. Now, between the different stations. Now, what does it station means? Stations means more number of users. There may be 1 user, there may be 2 user or there will be n number of users are there. Now, in this section we will discuss 3 different types of channelization protocols. Now, this is first one is known as the frequency division multiple access. Now, this is clear from this diagram that we have divided a different slots in terms of frequencies. This is frequency axis, this is time axis. So, this is time axis and this is frequency axis, and we have divided equal frequency slots, we can say, among n number of users. So, this will be 1, 2, 3, 4 and it can be extended up to n number of users are there. It means n number of transmitters and n number of receivers will be there to access a common channel, and all the available bandwidth will be equally divided among n number of users. Let us take an example of a bandwidth, channel bandwidth that will be equivalent to, let us say, 8 kilohertz. I am just taking an example, and there are 4 users are there that they have to use this 8 kilohertz of frequency band of this channel band. So, what you will see that 2 kilohertz each will be allocated to users. There are 4 users are there. The first user will going to use first 2 kilohertz of frequency, second user will going to use next 2 kilohertz of frequency. So, this each user will going to use 2 kilohertz of frequency. Now, this 2 kilohertz of frequency is totally not used for transmission of the data that has to be transmitted between the transmitter and receiver. Some of the bandwidths, let us say let us say this is 1.8 kilohertz of frequency is used for transmission of data, and this 0.2 kilohertz of frequency will be used for synchronization part. This will act as a synchronization or any additional data which will be required to maintain the channel, required to maintain the link between the transmitter and receiver. So, that 0.2 kilohertz frequency will be reserved, so that the interference will not take place between the 2 users. So, that will also known as guard band. This is also known as guard band. 0.2 kilohertz is known as guard band, and 1.8 kilohertz is basically used for the transmission of the data. So, this is how this 8 kilohertz of bandwidth you can see that this is equally divided among 4 users. So, this you can say that this is the data, this is the division of frequency, this is for the first user, this is second user, this is third user and 4 users. So, in this example also we have taken 4 different stations, or we can say 4 different users are going to accommodate a single common channel. Now, you can see that this first user, the frequency band is denoted by this blue color. So, this is for the first user, second user is using this yellow color frequency band, third user is using this color of frequency band, and fourth user is using this color of frequency band. So, this is the frequency bands that has been allocated to each of the station, and they can only transmit their information in their allocated frequency band. Let us say first user is having a data of 2.1 kilohertz, which has extended this range of 1.8 kilohertz. So, that particular data will not be transmitted, it will only allowed to transmit the data in 1.8 kilohertz of frequency band. Next, in the next cycle or next revolution, it will going to transmit their remaining data. So, this is how the transmission will take place. It will not going to take the frequency from the another user. Let us say it is if it is extended to 2.1 kilohertz. So, they can take their another user's frequency. So, that is not possible here. It will only transmit in the allocated 1.8 kilohertz frequency, and 0.2 will be reserved for the guard band. So, this is how this frequency distribution is possible in this frequency division multiple axis. Now, next we will see time division multiple axis. So, full form of this one is time division multiple axis. So, what does it mean? It means whatever total allocated time we will have, let us say we will have 1 hour of time for the purpose of transmission, and we are having 4 users, these are using a common channel, then you can easily calculate that 15 minutes are there for each user for the purpose of transmission. More than that they cannot transmit their data, after 15 minutes or after 1 hour, if the first user is having any data which has left for transmission, then they can transmit in the next cycle. So, this is how this time division has been divided among different users. You can see that this is the frequency axis, this is the time axis, and in this case we have equally divided the time among n number of users. So, this is for the first user, this is for the second user, this is for the third, and this is for the fourth user, and this can be extended to n number of users. So, n number of users can use a common channel. Now, this is the data that has to be transmitted by the first user, and you can see that the time that is allocated to this user is denoted by this blue color. Then second user is having the time that is allocated denoted by this yellow color. Third user is using this time slot, that is denoted by this green color, and this is going to show this pink color of time slot. So, this is how this time has been equally divided among n number of users, and these are going to transmit the data. So, this is nothing, it is the time division multiple access concept which has been shown by this diagram. Now, next is the foremost important, and this is somewhat complicated, but I will discuss it in detail, that is code division multiple access. This is code division multiple access. What does it mean? In code division multiple access, we will going to generate codes for each user, so that they can transmit their data. If we want to identify that which user has transmitted that particular data, then that will be distinguished by different codes that is unique to each user. If you will see in this diagram, this is the same division we are considering. 4 users are there, this is user 1, this is user second, this is user third, and this is user fourth. The data associated with the first user is denoted by D1, data associated with the second user is denoted by D2, third user is denoted by D3, and fourth user is denoted by D4, and the code that is corresponding to each of the user is denoted by this C1, this is denoted by C2, this is denoted by C3, and this is denoted by C4, and this shows that it is a common channel. So, how we are going to generate a data multiplied by the code, and these are added together, so that they can access a common channel. Now, you can see that D1 is multiplied by C1 only, D2 is multiplied by C2, D3 is multiplied by C3, and D4 is multiplied by C4, and all these data which is generated together, these will be added and they will going to accommodate a common channel. Now, these are the different chip sequences. Now, what is chip sequence? Now, chip sequence is basically generated by a table, we will going to see in the next slide, that is known as the Walsh table, or this is known as the Walsh codes. What is Walsh code? Walsh code is basically used to generate the codes that is required for the purpose of code division multiple access. This is denoted by chip sequence, and you can see that this is not this is fixed, you can say, and this is generated by a specific table that is denoted by the Walsh table, and the code we will going to see in the next coming slides that how this codes will be generated. Nothing is very difficult to understand or difficult to learn about, but you can see that all these codes are different. Like C1 is fixed, every time let us say 4 users are there, every time the user wants to transmit the data, and this is an example that is suitable when 4 users wants to accommodate a common channel. Let us say if there are more than 4 users are there, those wants to accommodate or those wants to use a common channel, then the Walsh table will be changed according to that. So, this is an example that is suitable when 4 users wants to use the common channel. So, this is the first code associated with this, and now you can see that all the ones is plus, positive ones are there in the first code. So, this is different from the second code. Now, you can see that this is plus minus alternate sign are there, plus minus for the second code. For the third code, this is plus minus. So, two positive and two negatives are there, and in case of this C4, that is denoted by the code 4. So, that will be plus minus plus. So, this is how this code will be generated. So, we will going to see in the next slide. And data representation, if a user has to transmit, because everything that is transmitted is in the terms of data bits only. So, if 0 bit has to be transmitted, then it has to be denoted by -1, 0 is denoted by -1, +1 is denoted by +1, means 0th bit is denoted by -1, 1 bit is denoted by +1, and if silence, means if nothing has to be transmitted, then it has to be transmitted using 0th level. So, these are the three different levels that has been required for the purpose of transmission of the data. Now, this is the diagram from which everything will be cleared. You can see that we have used this C1. Now, C1 is nothing, it is the code first for the first user, where all positive are there. Now, second code is denoted by plus minus, that is alternate sign are there. Now, the third user is having two positive and two negative, that is the third code that has been shown over here, and fourth is denoted by plus minus plus. So, this is for the fourth user. So, there are 4 different users are there. Now, you can see that first user wants to transmit this 0th bit. So, we are transmitting -1. Second user again wants to transmit 0th bit. So, -1 will be transmitted. Third user wants to transmit nothing. So, 0 will be transmitted, and it wants to, fourth user wants to transmit bit 1. So, +1 will be transmitted. So, what will be the formula? It will be D1 C1 plus D2 C2 plus D3 C3 plus D4 C4. So, this data we have to generate, so that it will be transmitted over a common channel. Now, you can see, let us multiply each one. When -1 is multiplied by all the positive ones, then the sign will going to change. This is very simple multiplication, only the sign will change. So, plus will be will become -1 -1 and -1. Then for the second user, when there will be -1, it will be generated as, when -1 will be multiplied by plus, then the sign will again going to change. When 0 will going to multiply with any, either it will be positive 1 or negative 1, then you will know that if 0 is multiplied by any of the bit, then the output will be 0. So, D3 C3 will going to be 0. Then D4 C4, this is again +1 will be multiplied. So, no sign will going to change. So, plus minus plus. So, this is how this code will be generated. Now, this is for the first user, this will be added to this one, then this one and this one. So, this is how the data will be generated. So, this is the common channel. So, this is equivalent to D1 C1 plus D2 C2 plus D3 C3 plus D4 C4. So, this will be transmitted over the channel. Now, how the signals will be created? You know that this -1, if you want to show it over a axis, then this will be -1, this will be +1 and this will be 0. So, bit 0 will be transmitted by -1, then -1 +1 -1 +1, it will be shown by this, and this will be +1 -1 -1 and +1. So, this is how this bit 1 will be transmitted. So, the data on the channel, if you are going to, what you will have to do, you have to just divide this into 4 different axes. Now, this 4 axis will be divided. So, this will be -1 -1 plus 1. So, this will be cancel out and minus 1 will, this is 0, minus 1 will become minus 1 only. When you are going to add this, this will be minus 1 plus 1 0, this will be cancelled together, this is 0 and minus 1. So, the output again will be minus 1. When you are considering this third bit, this will be minus 1 which will becomes minus 2 and this will become again minus 1. So, this will be minus 3. Then the last one, this will again cancel out, this is 0 and this is plus 1. So, the output will be plus 1. So, this is how the data on the channel will going to travel, that what you have seen in the previous slide, this minus 1 plus minus 3 and plus 1. This is not transmitted as it is, because plus 3 is nothing when we are talking about this 1 and 0. So, we have to denote it in terms of a signal, and that signal is shown by this diagram, this black colored waveform which has to be transmitted over the channel. Now, next is whenever, now since we have transmitted this signal, so definitely we are going to receive this signal only. So, how we are going to decode this signal, how we are going to see that minus 1, minus 3 and plus 1, we have received this one. From this we have to find out D1, we have to find out D2, we have to find out D3 and we have to find out D4. So, this is the main aim to generate this data. So, you can see that this is the station second code, we will see this is how, this is plus 1, this is minus 1, plus 1 and minus 1. This is C3 code, inner product result is denoted by this one. When you are going to multiply this signal by this signal, then you are having this one, and then summing up together you are having this signal. So, you can find out minus 1 which is the D3, this is equivalent to minus 1. So, this is the bit 0. So, you can find out for the particular channel. So, this is how the decoding will be performed. Now, I was talking about the Walsh table or the Walsh code, how this will be generated. So, there are certain rules when you are considering this Walsh code. Now, you can see that there are two basic rules are there. First rule is this one, whenever we are having this W1, it will be denoted by plus 1, and whenever this is having W2n, then this is W1, W1, W1 and this will be W1 bar, which means it is the invert of what we have taken the values for W1. So, generation of this W1, W2 and W4 is denoted by this one, this is W1, and how this W2 will be generated. Whenever we are considering this W2, then n will be is equals to 1, then this which means this is W1, this is W1, this is W1 and this is W1 bar. So, you have to generate this data. Now, you know that this is generated by this plus 1, plus 1, plus 1 and minus 1. Now, if you want to increase the data, then n next time n will be becomes 2, then this same table has to be repeated 3 times. This is same, this is nothing, this is W2, this is again nothing, this is W2, this is again W2 and this is W2 bar. You can see that 3 negatives and 1 positive is shown over here. So, this is the generation of W1, W2 and W4. So, these are the different rules that we have to consider for generating the Walsh code, and this Walsh code is very important when we want to transmit the data using this code division multiple access, because different codes has to be done generated. Whether 4 users are there, you can increase n number of users, then this table dimension will going to increase accordingly. So, this is the rule, these are the rules for Walsh code. Now, there is an example that you have to find the chips for a certain network with 2 stations and 4 stations. 2 stations means there are having the values that is plus 1 and plus 1 minus 1, which is the table Walsh code, that is W2. So, this first code has to be used by the first user, this second code has to be used by the second station. So, this is the code allocation for the 2 stations. When we are considering this 4 station condition, then this has to be repeated again. So, this code has to be used by the first user, this has to be used by the second user, this has to be used by the third user, this has to be used by the fourth user. So, this is the case for the 4 stations. So, this is about this slide is basically showing the references that you can see, that you can find out for the code division multiple access. So, in this lecture we have discussed about what is channelization. There are 3 different protocols are there, like first one is the frequency division multiple access, second one is the time division multiple access, and third one is the code division multiple access. And in case of this code division multiple access, you require Walsh code for the purpose of coding the data by the each user. So, these are the references that you can consider, and thank you.